Hello everyone, welcome back to my channel. This is your Mr. N speaking. Finally, on the second last day of this unprecedented 2020, I have decided to record this video to go through this year's Math Method Exam 2, concluding and commemorating this unforgettable year. Before I start, I must congratulate all of you who completed your Math Method course and or VCE this year. No matter what ATAR you have obtained, your hardworking efforts must all be commended, and bear in mind your VCE is only a past stage of your life and there will be more challenges and opportunities in the future. If you have obtained your desirable results, well done and keep it up. If not, don't be frustrated because you are not just sprinting but taking a long-term marathon. Cheer up and carry on. Then you will see more beautiful views in future. Well, as usual, here comes my disclaimer first. This video is just my personal suggestions to the exam and it is not intended to be exemplary solutions. In addition, these suggested video solutions is in no way endorsed by or relevant to VCAA official opinions, and it is for non-profit pedagogical usages only. Should you have any further queries or intend to obtain more specific information, please visit VCAA website and consult with the assessor's report coming next year. So let's get started. Here comes the very first question. So you have 4 statements. The value of g of f minus 1, which is g of the value of f minus 1. Here comes 4. So what is g of 4? It's 6. Therefore, we choose D. Moving on, let p of x be x cubed minus 2ax squared plus x minus 1. And a is a real number. When p is divided by x plus 2, the remainder is 5. Using our year 11 knowledge, we know p, the value of polynomial p at x equals minus 2, because you equate this one we call factor to 0. So you get x equals minus 2. Substitute that into the polynomial, it will be 5. Which is the remainder theorem, okay? So let's use our CAS calculator. X to the power of 3 minus 2a times x squared plus x minus 1. I think I need a given that x equals minus 2. Okay, so this expression will be 5. Therefore, a is minus 2. Question 3. Let f dash of x equal to 2 over square root of 2x minus 3. So it's an integration question, and f of x is just the integral starting from 6, ended up at x, 2 over square root of 2u minus 3 du, plus the value of f of 6. And let's have a look. Integral 6 to x fraction 2 over square root of 2u minus 3 du plus 4. So the final answer is 2 square root of 2x minus 3 minus 2. And the answer is C. Question 4. The solutions of the equation 2 cos 2x minus pi on 3 plus 1 equated to 0 are, right. So the quickest way is CAS calculator, of course. Solve button, 2 cosine bracket 2x minus pi over 3 plus 1 equal to 0, comma x. So you have two expressions as the general solutions, where n1 represents any integers, okay? Now, x is 6. Let me have a look. Okay, 6k minus 1 pi divided by 6. Here I use the letter k to represent any integer. The other one is 2k plus 1 pi over 2. Looks like we can't choose these two because they are 6k minus 2, not just x equals pi. So I need to choose between C or D. Which one should be the closest answer? Say if you multiply the second one by 3 over 3, you should get 6k plus 3 times pi over 6. So option D is a feasible answer, okay? Question 5. The graph of the function f defined on domain D. F of x is 3x plus 2 over 5 minus x. So I can put that expression in partial fraction form or proper fraction form. Let's have a look. Firstly, I need y equals expand. Then a fraction, 3x plus 2. And here comes 5 minus x, comma x. This is the standard form of a rectangular hyperbola. So it's minus 17 over x minus 5 minus 3. And the left-hand side should be f of x equal to minus 17 over x minus 5 minus 3. You have two asymptotes. Y is x equals to 5. Another one is y equals to minus 3. The domain is all real number backslash 5 in a curly bracket. So the correct answer should be E. Okay, let's move on. Question 6. Part of the graph of y equals f dash of x is shown below. Right, so we want to find from the derivative function to the original function. Let's say this one is grandpa. Now, he is the grandpa. He is the father. Well, I always use this analogy. F of x, original function. He is the granddad. And then the first derivative is the father. The second derivative is the son, okay? Anyway, let's have a guess on the shape. Let's see if we can determine the equation from the shape. Not very easy, but let's do this question in this way. So I duplicate a very similar shape according to the diagram given. If I translate this graph downwards, say here, almost, not quite, but almost, we should have, let's say this one is 0. You have something like, for example, let's say 2. If this one is -2, let's guess this one is -4. So I should say this root corresponds to a distinct factor x plus 4. This one corresponds to x plus 2. This one, actually, no, because that is a turning point. No, I don't need to do that. This one corresponds to x minus 0, which is x. And this one, repeated factor, x minus 2 squared. So the blue curve can be written as y equals to x plus 4 times x minus 2 squared. If I involve this upward translation, the black curve should be written as f dash of x, which is y plus a positive constant. Let's say x plus 4 times x minus 2 squared. Right. Let me remove this family tree and keep going. My best bet will be plus 2 if this one was a 1-to-1 ratio. The whole purpose of this procedure is preparing some button pressing steps on my CAS calculator. So from my deduction, the derivative function can be written as x plus 4 times x minus 2 squared as one repeated factor. Then add, let's say, add 2. Okay, so not exactly the same thing, but we can adjust the window settings. Let's say this one is 20. The bottom number should be minus 20. Not enough. Let's see if 40 works. Minus 40. Still not. Minus 60. Well, let's try 100. Much better. And this one should be, let's say, 40. All right. Looks like the same thing or similar shape. Then, if you want to find the antiderivative or the original function, you can just try integral. You refer to f1 of x at the beginning because you have already sketched f1 of x as well as defining it in this problem. So let's have a look. 100. 200. Should look like that. Let's try another number. Okay, doesn't change much. So we know the antiderivative should look like that. Therefore, the closest answer should be B. Okay. Move on, question 7. If I want to find the derivative of that function, which is f dash of x, we can directly go to our calculator and do things like d dx. E to the power of some arbitrary function, let's say g of x squared, if I'm not mistaken. from your CAS calculator output, you should realize, okay, e to the power of gx is already there, fixed. You can't do anything extra on this expression. But this expression can be further evaluated, because if you treat this one as, say, u, this is your u equals x squared. From chain rule, you can write it as e gx squared times the derivative of g of x squared, which means e gx squared times 2x times g dash x squared. So the correct answer should be C. Well, question 8. Items are packed in boxes of 25 and the mean number of defective items per box is 1.4. So let's say X means the defective items in one box. Then you can use binomial distribution with n equals 25, but p is unknown. The expected value of binomial distribution X is n times p. So 1.4 equals to 25 times p. Therefore, p is just 1.4 divided by 25, which is 7 on 125. And then with this binomial distribution, we want to find the probability that a box contains more than 3 defective items. So probability of X greater than 3, not greater than or equal to, okay? Probability X greater than or equal to 4. And now we know it's going from 4. The upper limit is the n value, 25. The p value is 7 on 125. So you can go to your calculator and speak out the magic spell. Menu 5, 5, B. This is 25, the number of trials. Probability of success, 7 divided by 125. The lower bound is 4. The upper bound is 25. Press OK. The answer should be 0.04849. So the correct answer, the closest answer should be B. Okay? Moving on. Question 9. Right. If integral 4 to 8 f of x dx equals to 5, then we want to find integral 0 to 2 f 2x plus 2 dx. Right. Here I want to apply a famous procedure, linear substitution, normally taught in specialist math, but it's very useful in math method. Here we go. Let everything inside the bracket be u. U equals to 2 loss of x plus 2, which is 2x plus 4. Then you immediately find the derivative of u, which is du dx. This will give you 2. Then you just treat du dx illegally as fractions, but you can't do that in your short answer questions or even extended response questions, only multiple choices, okay? Dx equals to half du, okay? This is the ratio between two differentials, two infinitesimals. Then these two terminals are x values. So when x is 0, the corresponding value of u will be 2 times 0, 0, plus 4 is 4. When x equals to 2, u will be 2 times 2, 4, 4 plus 4, 8. Now, remembering the order, so the integral starting from x equals to 0, which is u equals to 4. Then this bit is u equals to 8. F stuff will be f of u times dx, which will be half times du. Remember, you can relocate the constant half to the front. And your integral will be simplified to half 4 to 8 f of u times du. Compare this one with the given condition, 4 to 8 fx dx, which is 5. So 4 to 8 fu du, this bit will be 5 as well. So it's half times 5. Therefore, your answer should be E. Easy peasy, lemon squeezy. Let's move on. Given that log base 2 n plus 1 equal to x, the values of n for which x is a positive integer are, well, let's see the first one. If n is 2 to the power of k, let's say n equals 8. Log to 8 plus 1, which is log to 9, not integer. Let's say if n equals to 8 minus 1, which is 7. So log to 7 plus 1, which is log to 8. And this will be log to 2 to the power of 3. Okay, 3. Good integer. Let's choose B. Then you don't need to look at the rest of the options. Just move on. The length of plastic pipes that are cut by a particular machine are normally distributed random variable x with a mean of 250 millimeters. Z is a standard normal random variable. If probability x smaller than 259 is 1 minus probability z greater than 1.5. So let me paraphrase the right-hand side. This will be z smaller than or equal to 1.5, or you can just write z smaller than, okay? Draw a normal distribution diagram. This is x. 250 is in the middle. And x is a normal distribution, 250. And standard deviation is unknown. So standard deviation squared, sigma squared, 1.5. Why don't we just draw another number line right beneath the x number line, which represents z values. So in the middle, you always have z equal to 0. And let's say 1 standard deviation, 2 standard deviation, 1, 2. Here comes 1.5, okay? So your probability x smaller than 259 is equal to probability z smaller than 1.5. This can be re-expressed as z smaller than 259 minus the mean value, the actual mean value divided by sigma. So it will still be z smaller than 1.5. Therefore, you can equate these two expressions, 259 minus 250 divided by sigma, which is 3/2, 1.5. So 9 over sigma is 3/2. So sigma should be 6. A very nice by hand calculation question. Then we can look at question 12. A clock has a minute hand that is 10 centimeters long and a clock face with a radius of 15 centimeters as shown below. Right, so if I'm not mistaken, at 12 o'clock noon, both ticks are upwards, okay? Then it's just rotating in a clockwise direction like this, circular motion, okay? So that is the starting position. And if you have a compass, just draw a nice circle, okay? Like what I'm doing here. We relocate the position a bit. Okay, that looks better. We are actually measuring the height from the tip of the minute hand to the base of the clock face. And at the beginning, let me just draw one axis. This is your height in centimeters. Height against time in minutes. We know if it's 15 minutes past. Actually, I should draw a straight line. 15 minutes. Half an hour. 45 minutes. Okay, at the beginning, that's 0. 15 plus 10. T equals 0, H equals 25 centimeters. That's 15. So T equals 15. The height is 15. Another 15 minutes, you reached T equals 30. And this is the lowest height. 15 minus 10, 35. Again, another 15 minutes, 45. Roughly here, that is 45, 15. Exactly 1 hour, 60 minutes. Actually, I should draw 60 here. Use a ruler if you can. So if you sketch that function, this looks like a cosine function. Your amplitude should be 15. This is the center line, which we also refer to as upward shift. 15. Actually, the amplitude is 10, not 15. The period equals 2 pi over n, which is 60. So let's use y equals a cosine nt plus c. From this one, my n value is 2 pi over 60, which is pi over 30. My a value is 10 cosine pi over 30t plus 15, okay? Looks like option E. Moving on. Question 13. The transformation that maps the graph of that onto the graph of that. So this is my original. This is my image. The image function should actually be y1 equals to cosine 2x1 plus 4. Okay. Be aware of the forms of the matrix equations. If you don't have a bracket around these two matrices, It means you are doing the dilation and reflection first, then translation. So option B and option E are Dr. T. Dr. T. With the bracket, embracing XY and another 2x1 matrix, it means you are doing translation first, then dilation and reflection. So let's try this one first. This half means dilation factor of half away from the y-axis. It will make cosine of x to map cosine 2x, okay? But considering the order, it's x minus 4. So we can't just apply the dilation. I may need to adjust the procedure a bit. In fact, it's the translation by 4 units left or negative direction of x-axis. So you are making cosine of x to match cosine of x plus 4, okay? Then you are doing the dilation of half from the y-axis. So from here, you can write a new expression, x to become 2x. Y equals to cosine 2x plus 4. Option A is the correct answer. Of course, you can do the traditional mapping method. X1 is half x minus 4. Y1 is y, okay? 2x1 is x minus 4. X is 2x1 plus 4. And this is y equals y1. So y equals cosine of x. Y1 equals to cosine of 2x1 plus 4. Substituting that here and that one here. There we go. Option A is correct. Question 14. The random variable x is normally distributed. The mean of x is twice the standard deviation of x. So mu sigma. I would say mu is 2 sigma. Therefore, x is a normal distribution, mu sigma squared, which is normal distribution 2 sigma, sigma squared. Probability x greater than 5.2 is 0.9. So probability x smaller than 5.2 is 1 minus 0.9, which is 0.1. Here comes your mu, and because it's less than 0.5, less than, the probability area should be here, roughly here. Magnitude 0.1. Now I want to figure out its z value. This is your x. This is 0. This is z 0.1. Let's use the calculator. Manual inverse normal 0.1. Here is your z value, and you can try solve. Fraction button. The actual score is 5.2 minus 2 standard deviation, which is the mean value, divided by the standard deviation itself, will be that z-score above, and you are solving for S, the standard deviation. Let's grab the approximate value, 7.237. The closest answer is A. Correct to 3 decimal places. Let me double check again. Yes, it's looking for the standard deviation. If it's looking for the mean value itself, it will be option B, but here we want the standard deviation of X. Okay, average value. In fact, we have 2 straight lines. So the first part and the second part. Let's look at the first line. M1 is y2 minus y1 minus a minus 2a. x2 minus x1. 0 minus bracket minus 2a, which is minus 3a divided by 2a. So this will be minus 3 over 2. And the equation of the line is m1x plus c. So your c value is minus a. Y equals minus 3 over 2 x minus a. Okay, the second line, m2 is y2 minus y1, a minus minus a. This one minus this one, a minus 0. So this will be 2a divided by a, giving you 2. And the y equals to 2x minus a. Now, if you want to find the average value of the function, so f of x can be written as minus 3 over 2x minus a, x smaller than or equal to 0, and then 2x minus a, where x is greater than 0. Average value is a minus minus 2a, 1 over the interval length, integral from minus 2a to a, f of x dx. But you know the hybrid function has 2 pieces. So you need to write the first integral into 2 pieces correspondingly. The first part, the coefficient, is just 1 over 3a. Then you need a bracket from minus 2a to 0, which is the cost, the sharp point. You are using the first bit, minus 3 over 2x minus a dx plus 0 to a, 2x minus a, bracket, dx, bracket. So the next thing is using your CAS calculator and evaluate this whole expression. A over 3. Looks complicated, but if you know what you are doing, it will be not difficult at all. Oh, question 16, a typical F max, F min question. So you should have 3, 0 here. The area is A equal to half m times the y coordinate 9 minus m squared. Let's just use function maximum 0.5 times m times 9 minus m squared, comma m, comma 0 to 3. M is root 3. But don't forget to substitute the m value into the function, so you can get the maximum value itself. 3 root 3. Yes, it's looking for the maximum area. Essentially, what you are doing with f max is solving the derivative equal to 0 and testing the endpoint y values. And a max is a root 3, which is 3 root 3. Easy peasy, lemon squeezy. Let's move on. Question 17. A tangent to the graph of f has a vertical axis intercept at 0, c. But we don't know where the tangent is. So let's say, let a comma minus natural log a plus 2 be the tangential point. You can actually do a rough sketch here. Here is your only vertical asymptote x equals minus 2. And it should look like that. Okay? If I'm not mistaken, this is minus 1, 0, the only x-intercept. And here you have 0 minus natural log 2, the only y-intercept. Okay, so if you want to pick one point that yields the maximum value of vertical axis intercept, which is the maximum value of c, let's see if this point works. Okay, through this point, I've drawn a tangent line, and looks like the y-intercept is far below the x-axis. So what if we try the x-intercept itself? Okay, if I move from left to the right, I will see this y-intercept getting higher and higher. How about this point? How about the tangent at the y-intercept itself? Let me use another color. Let's use a green color. This point. Right. If I keep moving to the right-hand side, let's say this point. It's actually getting a lower, see? A lower y-intercept. Let me try one more point with a pink color. Whoa, even lower. So the highest possible C will be placed here. Therefore, this point will coincide with the y-intercept of the function f of x, which means my maximum value of C will be minus natural log 2. But how do I prove that in a calculus sense? Let's use our magic friend, whatever CAS calculator you have. We have already decided at x equals a, an arbitrary value a, where a is greater than minus 2, we can find the equation of tangent. So let's do this. Y equals to menu 49 on TI-Nspire, calculus tangent line. And the function itself is minus natural log x plus 2, comma, x, comma, an arbitrary value of x, which is a. So here comes our tangent line at x equals a. Then my target is find the value of c, which is the y-intercept. So I can substitute x equals 0 into this equation and solve for y, which is c. Let's do this. Up, down, comma, C. Replace Y with C. Replace X with 0. You should get some function like that. So now C is a function of A in terms of A. To get the maximum value of C, we need to consider the possible values of A, which is -2 to infinity. Instead of differentiating function C in terms of A, I'm actually using F max again. See? Once again, you use F max, but this question is disguised in a way that you can't directly realize the possibility of using F max. So you have to read the question carefully and draw auxiliary diagrams if appropriate, okay? Which will facilitate you finding out any potential CAS usage. So now I'm finding the maximum value of C by using F max. The function itself is defined on -2 to infinity. How should I get out my infinity? Let's see. Okay, infinity, there we go. So at A equals 0, you obtain the maximum value of C. Now copy this down and shift. Actually, on your CAS calculator, get the bar out by using control equal sign, okay? C is minus natural log 2. That's it. Question 18. A is greater than 0. B is any possible real number. Okay, let's just draw a diagram. X and Y. Doesn't matter where I put Y equals B as the horizontal asymptote because it's just a vertical shift. But you do need to notice A greater than 0. This condition is very important because you're using that to decide the general shape of this hyperbola. And it's going from -A to 0. Okay, where's 0? And Y is 0 exclusive because it's the only vertical asymptote. So the function around X equals to 0 is getting towards -infinity or positive infinity, okay? Right, but we can't extend the graph to the positive infinity or negative infinity. It's actually ended at somewhere like -A or A here. If you substitute X equals A into this function, A divided by A is 1. So A comma 1 plus B. If you substitute X equals -A, you will get -A, B minus 1. Looking at the Y values only, you should see, okay, from negative infinity to B minus 1, then 1 plus B to positive infinity. Therefore, your answer should be D, okay? Question 19 has proven the second difficult question in this paper, the second most difficult multiple choice question out of the 20 multiple choice questions. The hardest question was question 20. But if you realize the pattern, it will not be difficult at all. First of all, a 6 is rolled on a fair 6-sided die in 20 trials. So the probability density function will be W equals to W, and this is 20 trials choose W successes. So a 6, 1, 6, 1 phase out of 6 phases to the power of w. Then the rest 5 faces out of 6 faces. The remaining trials will be 20 minus w. Okay, now, if you are using this one, the probability density function for the number of times w, that a 6 is not rolled on a fair 6-sided die. Okay, now we better use another letter. Let's say x, x, x minus x. Not rolling a 6, that means probability of w equals w. Still 20 choose w, but this time we are swapping these two probabilities around. 5, 6 to the power of x, now to the power of w, times 1, 6 to the power of 20 minus w. The other way around, okay, so if you can realize, 20cx, 20cw, they match each other. Thank you, yellow highlighter. Then this bit corresponds to this bit. And you are comparing the indices. One is x, another is 20 minus w. So if you are substituting x equals 20 minus w, you should get this option here, as well as 20 minus x, w, 5, 6, 5, 6, okay? Therefore, you are choosing A. Looks quite tricky, but doable. If you want to interpret the answer in a graphical sense, you could argue that, okay, so if I go from P of x to P equals minus x, you are actually reflecting everything about the y-axis. And then if you go from P minus x to P minus bracket x minus 20, you are actually, let's say, shifting the whole probability function by 20 units in the positive x direction. So you can see this will be the resultant graph of that function, which is just taking the opposite event of interest, okay? Right, so question 19, finished. And let's look at the hardest question in this paper. Let f be a function restricted on real numbers. F of x is cosine A of x. It's a function with the following property: f of x equal to f of x plus h, and h must be any integer. This actually implies the period must be integer. So the simplest case is, okay, h can be 0 plus or minus 1 plus or minus 2 plus or minus 3, okay? The easiest case to analyze is h equals 1, which is your period. So the period is 2 pi over n. Here n is a. 2 pi over a equal to 1. So a is 2 pi. Okay, now f of x is cosine 2 pi of x. And log 2 cosine 2 pi of x is your function g, okay? G of x is that. It has a range of minus 1 to 0. So log 2 cosine 2 pi of x greater than or equal to minus 1, smaller than or equal to 0. 2 to the power of minus 1, smaller than or equal to cosine 2 pi x, smaller than or equal to 2 to the power of 0. and the cosine 2 pi of x smaller than or equal to 1 greater than or equal to half. Now, if we want to find a possible interval for D, then let's try to solve this equation for x. Solve. One over 2 smaller than or equal to cosine 2 pi times x smaller than or equal to 1 comma x. And you should get a domain like this. If you restrict that solve button with appropriate domain, let's say 0 smaller than or equal to x smaller than or equal to 2. Even more ugly. Okay, let's try some simple numbers. Let's try 1. Let's try 1. Okay, 5 over 6 smaller than or equal to x smaller than or equal to 7 over 6. So I think the closest answer should be B. Okay. In fact, for some certain values of C could be also correct if you are choosing A equal to pi, okay? I will leave this one as your own exercise to delve into, especially with your CAS calculator. But the best answer, as far as I'm concerned, should be B. Okay, looks like we spent a heaps amount of time discussing the 20 multiple choice question. I tried my best to discuss each one in details, highlighting some CAS calculator usages as well as possible by hand approaches. Be prepared to look at the second part of this video. I will be recording the second part after I take a break. See you later.